All right, so I wanted to make just practice plotting points on a semi-log plot, just to better understand what these plots are all about. You will likely not have to actually graph something on a semi-log plot for the AP exam. Instead, you will probably need to, given a set of data, you'll probably need to pick out of choices of graphs which one is the correct semi-log plot. Okay, so I want to graph these points on this grid, and they range from 18 to 146,041.17. So here's the first thing about a semi-log plot. Take a look at this. Now, they typically have these sort of lines that change in like how far apart they are. They don't always look like this. Sometimes they leave these horizontal lines out like we had in our notes, and they just show you what's happening here. So here's the first thing to note. I like to, instead of having their exponent version, I like to have like, what number is this? This is 10. This is 100. This is 1,000. 10,000. 100,000. Let's go higher than that. Oh, yeah. 1 million. So in general, if I'm trying to plot, say, 500,000, I'm going to be up in this upper tier. If I'm trying to plot 20,000, well, 20,000 is between 10,000 and 100,000. Okay. And then why are the lines weird? Well, because the scale is changing in every section. So in this section, each line represents one. So here's, we've got 1, 2, wait, is 1 down here? No, sorry, 1 to the 0. 1, 2, 3, 4, 5, 6, 7, 8. Oh, yeah, okay. 1 is down here. That's weird already. 2, 3, 4, 5, 6, 7, 8, 9, 10. And then up here, now we're counting each line is 10. So 10, 20, 30, 40, 50, 60, 70, 80, 90. So you get the idea. It kind of starts off kind of wide and then we scrunch it down in. Why is it like that? We're trying to condense data so that if I were just to graph on a normal, say I'm in Desmos, I'm going from 18 to 146,000. It's going to look really strange until I get to like, there will be a huge difference between these last 2 points, but these first 3 will probably just look like a flat line. So this is to help spread the data out a little bit. Sometimes we say it straightens the data out. It's just sort of a different scale to use. That's helpful when you have such a huge range in your range. All right, so let's get down to plotting the points. Now the horizontal axis, notice this is just like 10, 20, 30, 40, 50. So yeah, these points, I'm only going to, I didn't think this out very well. Let's change this to like 1 and change this to 2. Our data set only goes to 5, so it would be silly to have our points all scrunched in here. Let's do that. Okay, so I want to plot the point 1, 18. So 18 is between 10 and 100. It's a little bit less than 20, so I'm going to go to 1 and plot a point at roughly 18. I'm not worried about the decimal places. I'm just kind of thinking whole numbers here. The next point I want to plot is 2 and 176. So 176 is between 100 and 1,000. And remember, this is, so now we're counting by 100. So here's 200, 300, etc. So 176 is going to be a little bit short of 200. So maybe here. All right, the next one is 1,656. So 1,600 is what I'm thinking. That's between 1,000 and 10,000. Now these count up by 1,000. So here's 2,000, 3,000, 4,000. So where does 1,600 fit in? Roughly here, right? What's the next one? 15,500. So 15,000 is between 10,000 and 100,000. And in this section, each line is 10,000. So this isn't very exciting because I kept having something in between this first number here, but you get the general idea. 146,000 is the next one. I'm going to throw in some extra points just so we can plot something else. So each line goes up by 100,000. So from 100,000, the next line is 200,000. I'm trying to plot 146. So 146,000. Now I'm going to make up some points just to plot. They don't necessarily have to do with this relationship. So let's plot the points 1.5. Oops. 1.5. And let me look at my graph. How about like 78? Again, this might not fall in line with the grid. All right, so where is that going to be? Well, 1.5, first of all, is right here. Where does 78 fall? It's between 10 and 100. So here's where I'd have to pay attention. Okay, 20, 30, 40, 50, 60, 70, and 80. So it's like somewhere between these two, something like that. That actually did fall in line pretty well. What if I wanted to plot 3.5? And how about like 8,500? 8,500 is between 1,000 and 10,000. So 2,000, 3,000, 4,000, 5,000, 6,000, 7,000, 8,000, 9,000. And we're going over to 3.5. It was 1, 2, 3.5 between 8 and 9,000, something like right there. Okay, so this is just a practice plotting more points. If we truly have exponential data, we can verify that two ways. If f of x is exponential, the semi-log plot is supposed to look roughly linear or perfectly linear. It depends on if the data is perfectly exponential or not. These points in red, ignoring my made-up points, those do fall into a nice linear pattern. You can also check by dividing consecutive terms. If you get the same or a very similar common ratio, then you know that's exponential as well. All right, so hopefully this kind of clears up like how to work with these kinds of graphs and what they look like. If you're choosing a semi-log plot in multiple choice, the first thing to look for is like which ones have this sort of gradation, like variation in the lines in between powers of 10.